Kosta from Infobip. Infobip is a company based in Croatia, and they both are part of the team that actually started working on their voice infrastructure basically from scratch. They recently started moving towards VoIP and WebRTC, and they've started doing great things with it. And I'm really curious about how they actually involved Janus as part of this process. So I see basically they'll describe the WebRTC platform they're starting to build around Janus. So please let's give a warm round of applause for both of our speakers and enjoy.
Thank you. Just to check if you hear me well. Okay, great. So I will just skip this slide because Lorenzo already introduced us. So I will say now a few things about what Infobip does. We are basically a communication platform as a service. It means we are connecting our clients that are some businesses to their clients. So whenever our client has some message to deliver to the end user, we are the ones that are actually delivering it. So we can do that because we are omni-channel oriented. What does that mean? Well, if some business wants to contact its own user, we know how to find them, whether it's by sending an SMS message, by placing a call to his phone number, by finding him on the Viber and sending a Viber message, or email, or anything. We have all modern messengers included there. So we know how to find people and send them messages. That's basically our business model. So we are quite big. You can see some numbers here displayed on the slide. We have like 500 microservices deployed, 3,000 virtual machines, and we have users that are divided in two categories. Those are API and SDK users. Those are some developers that are building their own applications and want to use our own communication infrastructure. And then we have clients that are just using our portal to send some messages or bulk of messages. So how does WebRTC fit into everything? Well, this new WebRTC world is emerging, and we want to be part of that since we are a communication platform. And we had existing clients that are asking if we can integrate them to our SIP platform, but using WebRTC, because it is way easier to integrate clients using WebRTC than just have them implement whole VoIP and SIP stack inside of their applications. And then we decided to do some proof of concept for those clients. And Janus was just the simplest WebRTC server that shipped with SIP plugin, and we just could use it for the beginning, and it worked really well for us. We did some proof of concept. Clients were satisfied with that, and then we decided to build a whole WebRTC platform on top of that proof of concept. So that's why we continued to use Janus and its SIP plugin. So in the end, what we built, well, we tried to call WebRTC challenges and problems that you must deal with when implementing WebRTC solution. And then we tried to solve those problems and offered those solutions to our clients, like signaling is not defined per WebRTC, and we implemented that, and that's one of the key selling points that we sell to our clients, that we have every challenges and problems resolved. So basically, our product consists of a platform. It's something that our users can connect to, and they can be registered to our platform, and they can easily talk to each other by using just few methods from our SDKs. On top of that platform, there is WebSocket API. It is used to actually connect those users to the platform, and we wrapped those WebSocket API calls inside of client SDKs. So currently we have web JavaScript SDK, Android SDK, and iOS SDK. We have them released, so we have clients using them. Basic idea was that anyone can just read a 5-minute tutorial and write few lines of code and have an in-app calls ready. So because we are dealing with clients that do not want to spend time and money to build their own infrastructure for in-app calls, they just want to use something that is already done. So how it's used? Well, as I already mentioned, there is an Infobip platform as a heart of everything. Let's say there is one user, Alice, and it can register to our platform in one line, and it is really important that it is easy to use, because it's our selling point to the clients, that everything must be a one-liner. So Bob can register to a platform in a one line, and now that they're both registered, Alice can call Bob also in a one line, and Bob can receive an incoming call also in a one line. And inside of this event, there is some kind of stream that you can just paste it on the HTML element, and everything works. So since we are using Janus, it probably looks something like this. Well, it's not quite like this. We have our own WebSocket API deployed in front of Janus. There are many reasons why we did this. The most important one is custom authorization. So whenever someone registers to our own platform, we can authenticate it against our own user base. With this kind of setup, we can have Janus farms deployed, and we can do load balancing with it. We can have a stable API, which means when Janus maybe changes its own JSON API, we can upgrade to new versions, and our clients does not need to change anything because our own API is stable. So let's talk a bit about authorization. How do we handle it? Basically, it's a token-based authorization. We have a REST API endpoint that you can use to generate a token for a user. And when someone has that token, then it can be used to connect to our WebRTC platform. But you need to understand that our product is an SDK. So that means there are a lot of mobile applications around the world that run our SDK inside of it. And there's our clients also, they have their own authorization servers because they develop mobile applications and they need to check their users against their user base. So these are the components here. As I mentioned, this is our own REST API for generating tokens. This is our own WebRTC platform. These are mobile applications developed by our own clients, and these are their authorization applications. And the key part here is who generates the token. Well, this thing here generates the token by calling our own REST API server, and when this here has a token, then it can be used to connect to WebRTC platform. So it looks something like this. This is animation showing what I already described. So at this point, we can check if token is valid and whether to let user use our platform or not. One another selling point is that we deal with load balancing, so our clients do not have to deal with it. So what does that mean? We have Janus farms deployed. We have multiple Janus instances deployed, and they are acting as a standalone instances. They do not communicate between each other. So what we implemented client-side balancing. So it looks something like this. Let's say we have 2 active Janus instances and 1 inactive Janus instances. And Alice wants to register to one of them. And first it connects to our own WebRTC platform. And we have employed a component named service registry. And whenever we start a new Janus somewhere, it reports itself to a service registry. So our own WebSocket API can ask a registry, okay, what are active instances of Januses? So it looks something like this. Whenever Janus is started, it reports its status. And when Alice wants to connect, we just ask service registry, okay, give me Janus instances. And then when we have it, we can load balance between active instances. And then we also keep checking the inactive instances if they are back alive, because we can shut it down due to maintenance reasons. It can just kill itself, I don't know. The main thing here is when we deploy a new Janus instance, it reports itself to the service registry, so we do not need to change some static configurations. With that setup, we have auto discovery deployed. So now Kosta will take over.
So communication between multiple instances of Janus was an issue we needed to solve in case one client was registered to one Janus, another client was registered to another Janus instance. And considering we were just starting with this new technology, we were looking for a quick and dirty solution, and the easiest one was this. So simply move the connectivity between users on the SIP domain through Sophia SIP stack, use Camellia as a registrar, register all users, and Camellia knows where individual user is. There's actually no authorization on the back end because Nadin takes care of all the authorization on the front end part with his signaling proxy on the custom JSON side. Now, this topology is not by itself redundant, so 2 Camellia nodes are required, and we use the simplest possible deployment. We use direct DMQ messages for replicating status of others of records between the nodes. If one node goes out, the other one still works. Everything is still in memory. on the premise that registration information is not needed to be persistent. So after X minutes, it can all go away anyways. This topology also gives another benefit, is that two Camellia instances look like one. So you have just one IP address. And this simplifies communications to the rest of Infobip services. Because Infobip, before WebRTC, has developed a bunch of SIP services, conference bridges, IVRs, text-to-speech services, and so on, number masking, etc. And communication with those services depends on our custom routing engine, which can expect a single endpoint, doesn't really track registrations and such, because we usually peer with our customers. And for WebRTC, this was the easiest solution because the whole WebRTC domain is hidden behind one IP. You can have multiple Janus instances, and our SIP domain system doesn't need to know anything about that. It just sends it to Camellia, and it will be delivered wherever it's necessary. So this communication means that we can reuse our routing logic on outbound calls. So if we have a WebRTC client connected to our Janus somewhere, and it needs to go out and needs to hit a specific service, it just sends it to Camellia. We don't need to have any logic on Janus, and Camellia can ask our existing routing system, which has like years of development in it, in a standard way, find me the service. And also in the other direction, if some other service needs to terminate on WebRTC, for example, number masking, one leg of number masking, or contact center or something like that, it also doesn't need to know anything about WebRTC. It just sends a call to Camellia, and Camellia will find the appropriate user in that data center. Of course, all this means that from my point of view for SIP architecture, WebRTC is just a new exciting type of access. But what kind of access? It's the perfect access. I've tried to implement access on SIP clients with registrations previously in telecoms, and it was a horror show. This is wonderful. You get stun, you get encryption, you get turn servers. Everything just works. And, well, works considerably better than the previous version. And we deploy our own stun servers, we deploy our own turn servers in AVS, and this is a marketing note. I think our model won't actually charge for turn servers for our services, but that's maybe not all that interesting. So from a SIP perspective and our existing services, this is it. Nothing else is necessary. It will just work. It's all integrated thanks to Sophia Stack integrated in Janus, and a couple of bugs we polished with Meteco guys in our early integration time, and that worked just fine. And now back to Nadin for geo-redundancy stuff.
Yeah, back to the WebRTC part. So one another problem that we are solving for our clients is geo-redundancy. So basically we have more than 30 data centers in Infobip. We have WebRTC deployed in few of them currently, but we are expanding this number continuously. So how do we deal with this? Well, basically, every new data center is a platform deployed by itself. Data centers do not know about any other data centers, so they are completely separate platforms. Then how do we do geo-redundancy? Well, in all data center, we have two things deployed. First is REST API. It is an HTTP endpoint that you hit to generate a token that we talked about previously. And the second endpoint is this WebRTC URL. So you can see this. This is a token URL. This is WebRTC platform URL. And when the token is generated, we actually use JSON Web Token, so we can put some information inside of that token. So basically, we put an URL to which WebRTC platform to connect to when we generate the token. So when this Alice receives a token, then it can read this URL here, and it knows, okay, I will connect to the New York WebRTC platform. The cool thing is that if we here know that our New York platform, WebRTC platform, is down, then we can just switch it to Frankfurt WebRTC platform, and this URL here will show Frankfurt URL. So cool thing about this is that clients do not need to know anything about this. It's all implemented inside of our client SDK, so we can just switch it seamlessly, and clients do not need to change anything. One thing that clients need to know about is which URL to hit when generating a token. We will deal with this also later. So we will have one endpoint that hits all data centers. So yeah, we also have a concept of mini data center. Well, in some countries we have legal regulations that says, okay, we must keep all media inside of that country. So that's why we need to deploy some media components in that country in our own data centers, but we do not deploy whole infrastructure. We just deploy these components that are dealing with media. So we have like maybe 10 data centers in Infobip that do just that. Okay, to the next slide. Even if our clients solve all these problems that we are solving for them, they will still probably not do any monitoring of their own platform. So we are doing monitoring for them. The key part is that we are sending all logs from mobile devices and web browsers to our own platform. So at any given point, we can see what happened on any mobile device that runs our own SDK. So we have all those logs and events stored on our central Elasticsearch cluster. It's some kind of gray log. We even have media statistics there, so we can draw nice graphs and see what actually happened on our client sides. We also log everything. We send Chameleon, Janus logs to the gray log. We have SIP traffic on the Homer, so we can debug stuff. And we have some custom application metrics and alerting, and it's based on the Prometheus. In the future, we will employ an anomaly detection algorithms. We already have that for every traffic that is not WebRTC, but we will have that for the WebRTC in the future. So what does that mean? We will just check traffic, and we will try to detect some anomalies in it and detect problems even before they actually happen. So our client does not need to know about any downtime that we experience. So this is some kind of screenshot from the Grafana showing that for every call that happened, we have client statistics here with all fancy metrics, bytes received, jitter, packets lost, and everything. This is some screenshot from a gray log that we can see here that for every call, we have every ICE connection state change, every call transport statistics and everything, and we can easily debug what happened. And this is some just random Homer screenshot. We also, this is Homer 5 actually. Kosta keeps promising that he will deploy Homer 7 by the end of the year. Okay, we also did, after doing everything, we also did some load tests, and there are a few notes to know about these numbers. All our instances are running in a virtual machine that is basically deployed on a shared Hyper-V cluster. We do not have any custom hardware for anything, even Janus that is dealing with media processing. And the real bottleneck here is Janus because it is the only component in this that is doing media processing. So for every other stuff that is not Janus, we have some classic virtual machine setup with 2 CPUs and 4 gigabytes of RAM. And Januses are deployed on machines with 4 CPUs and 8 gigabytes of RAM. And during these load tests, we had 2 instances of Januses deployed per data center. And our platform actually can handle 1,200 simultaneous calls with this setup. We also did some test calls to check if media is really still of good quality, and it really is. So that's it. We can handle 1,200 calls. And the big thing here is that we have employed horizontal scalability. What does that mean? If we need more calls, we just deploy new Janus instances and we have more calls. One other feature that we implemented using Janus is recording. So you all know that Janus can record the calls and they appear as 2 audio files, local and remote audio on the file system. And after the call is done, we just take any unmerged files and we merge them together. And then we deploy, we upload those files to the AWS. And we have developed some public API that you can see all your recordings and filter them by anything. And inside of the filtering result, there is an URL so you can download your file. We actually have this challenge here. It's a legal regulation. As I already mentioned, there are some countries that we must keep media inside of them. Well, we cannot have recording in those countries if AWS does not has its own servers there. Because media, even when it's recorded, it must be kept inside of the country. So a few notes about our platform. All of our services are Dockerized, including Janus. Everything is high availability mode, as we showed you, even Janus and Chameleos. We have multiple data centers across the globe for geo-redundancy, and we have one in-house developed tool called Deployment Manager that allows us to deploy any feature in a matter of minutes. So you just select which data centers and which versions you want to deploy, and one click and everything is deployed. So we can move quickly with the features as we develop them. We also developed some plans for the future. So everything we talked about is actually peer-to-peer calls and audio calls. Well, currently we do not support video calls, but in the future we will support video calls. We will have some methods inside of our SDKs that will with conferencing. We will implement simulcast, and future is bright. Yeah. And fun fact for the end, you all know how Janus got its name. We took that a bit step further. We named all of our microservices after Roman gods. The WebSocket API that we talked about, it's actually named Portunus because it is a Roman god of ports, doors, and keys, and it was a good friend of Janus. So here you can see all of the Roman gods that we have deployed around the globe. Yeah, and it's time for some thanks. Thanks for the Lorenzo and the Mythico team for this wonderful event. Thanks for the sponsors, and thank you guys for listening.
Thanks for the kind words. And by the way, Nadine told me at the beginning that this was his first time presenting publicly. I think he did an amazing job. So kudos to you.
Thanks.
Do you have any question for Nadine and Kostas? There's Lorenzo in the back.
Sorry. How did the GDPR impact the way you record and collect data, especially data coming from user agents?
Well, for the starter, that recording, we do not do it always. Client needs to explicitly say it wants to deal with the recording. So clients need to notify us if we will do the recording. So, and also he can notify us that we can stop the recording process. So we do not record anything unless client decided that he wants those recordings. So that's one factor of the GDPR. And second one is, well, I don't know if it's GDPR, but it's legal regulation. The one I talked about, that we need to keep media inside of the country where it happened. But yeah, a client needs to tell us explicitly, and we need to store that the client's decision somewhere in our logs, so we can say, okay, they told us to record. We didn't do it by ourselves.
Also for monitoring, he's asking Lorenzo.
We do not for monitoring. We do not record anything. So currently, we do not have monitoring implemented with the recording. We just save logs. What happened with the call? So there's no kind of sensitive information inside of our logs.
Hi, thank you for the talk. Have you measured how much data bandwidth are you spending by sending all those logs from the SDKs up to your API? How much impact might it have in mobile connections?
Well, we didn't explicitly measure that, but since we are just starting here, we do not have many clients using that. So for now, we just store all data, and we have some simple Elasticsearch clusters, not more than 50 gigabytes of storage. So we store everything for now, and if we have problems, then we will deal with that. We do not have many logs currently.
Just
to add to this answer before, we send all logs only from JavaScript, all media statistics there. From mobile devices, we do not send everything. We just aggregate everything at the end of the call, and we store like aggregate data. So we did that also because of battery consumption. So mobiles are pretty much different than web.
With this media stream staying within the country, is the client on the public internet, or is the link between your platform and the client controlled by you?
Can you please repeat the question?
Is the connection between the client that's creating a media stream and your platform over the public internet, or is it something you control? The connection itself, the underlying transport layer.
Uh, well, it goes through the public internet, but it all of the endpoints are located in the same country. So even if the media is going through the public internet, it cannot leave the country. So
How do you control that? That's my question here. Because, well, the way the packets will travel the internet depends on the BGP protocol that you don't really control. And furthermore, it's dynamic.
So this is done per country because different countries have different rules on what can be done, and those rules also apply to different parts of the service. So for example, some countries will say we need to have media within the country, but they never actually specify media because usually those are telecom regulators that say stuff like that. They usually say something like call content and call control. And then you enter into negotiations with the telecoms to get license for interconnection because this WebRTC part usually comes second. First is the interconnection to the local telecoms in the country because most of our services are they usually break out into the mobile network or PSTN on at least one part. And telecoms usually require permission from the regulator to have a connection for certain services, and then you negotiate. For some countries, they are fine if you just have a local endpoint within the local telecom, and you keep just media locally. Some say no, all kinds of call control need to say local, then we need to push that also to the country physically without servers. And since we operate all around the globe, usually that does not mean AVS. It means our servers, our guys have to go there, do the gritty stuff, connect everything, integrate, and for it to work. And then usually is the issue that you have also some sort of business logic connected to the call. That's also subject to negotiations. Some countries say, no, 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 absolutely everything needs to be local. Then we need to open up the purse and build a whole data centers with racks and racks of equipment to facilitate all the backend that is not even mentioned here for this to work for billing, charging, and so on. Sometimes we manage to negotiate, okay, that part can be remote. We just need to be sure that call control and media stays local. That's the most often case. And then we just push SIP components and the media components locally. And for example, API calls are not strictly considered call control for routing, depending on the regulator you speak to. So it varies a lot, and basically that's part of our sell because we do all that hard stuff so that Nadin can come and do just a little bit of magic with WebRTC and it works.
Right, okay, thank you. A lot of fun.
Thanks. One last quick question.
I'm curious about how did you do scaling with Docker? Because as I know, when you open a wide range of pods in Docker, it doesn't work effectively. So is there some cheats here, or it just work smoothly?
well, for us, it all worked smoothly. So we didn't have any issues. We just opened a big range of ports and everything worked. So
Thanks.
Thanks. One last round of applause for our speakers. Thank you.
okay, thank you, everyone.